Let us now have a look at autosomal dominant conditions. In this case, Huntington's disease, Huntington's disorder. This is a degenerative disease which, if you have carried the allele, then you will develop this later in your life. It is a form of dementia. Oh, yes, that's an issue where essentially you become more and more dependent on other people as you grow older because you start to lose body control. And in this case, capital H is the allele for Huntington's disorder. And if you carry a capital H, the dominant allele, then you will develop Huntington's, and lowercase h is the normal allele. So it's the other way around to the autosomal recessive conditions. A person who developed Huntington's had children with a person who did not. How many percent of the children will get the disease? So if the person developed Huntington, then we know there must be a capital H present. And the person who did not have the disease must be homozygous recessive. Lowercase h, lowercase h. Now, the question is now, of course, over here. Now what? We have a capital H over here. Do we have another capital H over here, or do we have a lowercase h? We have to look at the parents, strictly speaking, to find out. So we're missing a little bit in information, so we have to make an assumption, and I assume, because Huntington's disease is not so very common, that it is heterozygous and that the person is a so-called carrier. No, it's not a carrier. This person actually has Huntington's. So this person carries the recessive allele. So we do the crossover here. Capital H, lowercase h, capital H, lowercase h. We do the cross. We do the cross here as well. And over here. So if one of your parents had Huntington's and the other parent did not, then you develop, you have a 50% chance of also developing it when you get older. And so the genotype is 1 capital H lowercase h to 1 lowercase h lowercase h. The phenotype ratios are 1 affected person to 1 non-affected. Okay, so that is the difference here is that the allele for Huntington's is a dominant one, and therefore it's much easier to pass it on to the next generation if the allele travels in a family.